In the previous lesson I was talking about infrared spectroscopy and how infrared light of different wave numbers or wavelengths gets absorbed by different bonds as they bend and stretch. I've now brought up a section of the Table 1 from the data sheet that you have with you in an exam. Table 1 shows the infrared absorption data, and it shows all of the different bonds and what wave numbers or wavelengths correspond to the absorption. So say for example a CH bond absorbs between 2850 and 3300. Remember, you're reading right to left, the scale goes the other way. So let's have a look at the previous one and let's just check that out against the table. We've got a trough here at around about 3,300, 3,400, reading from right to left, 3,100, 2,300, 400. It's quite a broad trough, which means it's quite wide, and that always corresponds to an OH, an alcohol. So a nice wide trough, unlike these sharp ones here, a wide one is an OH, an alcohol, and it's corresponding to around about 3,300, 3,400 wave number. So I think that's an alcohol. Let's read it. OH alcohols 3,230 to 3,550. Yes, it fits within that range. We reckoned our trough was around about 3,300 to 3,400. So it's definitely an alcohol trough. So there's absorption happening as the OH bond stretches here, and it's a wide trough, so I suspect that means it's an alcohol. That's making me think it's an alcohol. Let's have a look at the next one here. I've got another wide trough here, so another alcohol, but it's not at the right wave number. It's at around about 3,000 rather than 3,300, 3,400. So it's definitely an OH because it's so wide, but it's at the wrong position. And that's because this is an OH in an acid. That's a carboxylic acid in a COOH. So if you look, there's two kinds of OHs. There's one in an alcohol and there's one in a carboxylic acid, and they're at different wave numbers. So this one is around about 3,000, whereas the previous one was around about 3,300, 3,400. It's a wide trough. It's a little bit sharper. It's got like a sharp point on it as well, which is a good indication that it's a carboxylic acid. And it's at around about 3,000, so it fits in here perfectly, 2,500 to 3,000, somewhere in this range. So this one is a carboxylic acid. It's got something here as well, which also makes me think it's a carboxylic acid. At 1,500, 1,600, 1,700. There's a trough here at 1,700 which fits in with a C double bond O. And remember, a carboxylic acid has got a C double bond O and an OH. So these two together make me realise that it's a carboxylic acid. I've got something else going on here, but I can't really determine it. This is the fingerprint region. So if I didn't know what kind of carboxylic acid it was, I could run various different carboxylic acids through the infrared spectroscopy machine to determine that it would be ethanoic acid, because ethanoic acid would match with this fingerprint region here. Just to finish off then, most molecules containing covalent bonds are capable of absorbing infrared radiation. Methane, carbon dioxide, water, water vapour. In the case of these gases, in the atmosphere, the infrared radiation has come from the Earth's surface, preventing it from escaping. Eventually the molecules release energy as infrared radiation and may cause global warming. I think we covered that in a previous lesson as well. Now there are some past papers to cover here as well. Specimen 0.5, 4.5 and 16, Specimen 2, 4.1, 4.2, 4.3, 4.4 and multiple choice question 23. June 2016, 3.7, 4.1, 4.2 and 9. 2017, 3.1, 12 and 20. 2018, 6.2, 6.5 and 7.1. And 2019, 1.1, 1.2, 1.3 and 23.